This is going to be our first video for Unit 3. Unit 3, Day 1. So what we're going to talk about today is just some properties about working with algebra, so moving things around algebraically, so working with polynomials. So you see that word a lot. You've probably seen it in your Math 1 class a lot. We'll talk about what that means. So in algebra, we see a lot of our expressions involve numbers and letters. I have numbers, letters, or both. So if we take one of those or more of those expressions and put them together, that's called a polynomial. So each piece of the polynomial, each part of it, is called a term. So term can include variable, like x or y or a or b, any of the variables we've used so far. Coefficients, which are numbers in front of the variable. So we see 3x, 3 would be the coefficient. And also exponents. Right, powers of the variables. These are all going to be whole numbers when we're working with polynomials. So the highest power or exponent of the variable, that's important, it's of the variable, might not be the highest exponent in the problem. We're looking for the highest exponent on the variable. That's called the degree of the polynomial. So when we look through a polynomial, it might have a whole bunch of terms. The one that has the largest exponent, that's called the leading term. The reason it's called the leading term is because the way we usually write polynomials is in descending order. Right, which means we start with the highest degree term on the left and we work down in powers till we get to the lowest degree term on the right. So that's a lot of vocabulary thrown at you all at once. But you know what a polynomial looks like, you've seen them already, so don't want to get hung up on that. Word important thing here is let's be able to identify what the degree is. So first thing we're going to do is, on this example, put it in descending order, get the degree. So descending order means highest order, lowest order. So highest order here, I have x to the first, I have 4x squared, 5x to the third, negative 17. X to the third is the highest power on the variable. So we start with 5x to the third. Alright, next highest power on the variable, which is x, will be x squared. So I go with 4x squared next, then x, and then minus 17. So this is now descending order. So this 5x to the third, this is my leading term. The 5x to the third is called the leading term. Our leading term has the highest order, so this 3 right here is the highest exponent on the variable, highest power of the variable. That's the degree. So if this one right here, the degree is 3. The next question says, what's the coefficient of x squared? Alright, so here's my x squared term. Right, remember, x squared is called quadratic. Right, so that's our quadratic term. Alright, so coefficient of x squared would be 4. Right, we could also say, what's the coefficient of, using this vocabulary, the quadratic term? Right, those mean the same thing. Right, we're going to get into now those names. for the polynomials based on their degree. So some polynomials have special names. Those names are based on the degree. So if we have degree 1, which means just plain x, x to the first power, has the highest exponent on our variable, that's called linear. Whereas just like we saw in the last unit, graphing linear functions, right, it was always some number multiplied by x and then a constant. It's just a plain number. Right, so these would be examples of linear terms. Right, 6x, right, it's the same thing as x to the first power. Where here we have negative 3x plus 2. Right, x to the first power is still going to be the highest order, highest power of the variable x. So that's why it's linear. Degree 2, right, like we just talked about, is called quadratic. Alright, so anything with x squared is going to be quadratic. Alright, when that's the highest order term, it's a quadratic polynomial. Alright, any term that contains an x squared is called a quadratic term. Alright, this next part here is for you to practice on your own. I know we went through a lot of vocabulary there, a lot of information, but there's 3 things you want to focus on here. Number 1, always want to make sure to write polynomials in descending order. So start with the highest powers on the left, work down to the lowest powers on the right. Name the degree. Once you put descending order, that's easy. It's just the highest variable that's going to be on that first term. Also state the number of terms. Alright, so 3 parts. You're going to write in descending order, name the degree, and state the number of terms. So the next thing I noticed, something you've done before also, is combining like terms. So we use this phrase a lot. What we really mean is adding and subtracting. When we're adding and subtracting polynomials, there's only certain terms we can combine. And those are called like terms. So like terms, terms that we can combine in polynomials, have 2 things in common. The first thing is they have to have the same variables. Alright, so I can't combine x's and y's, right, or z's and w's. It has to be the same variables. Second thing is those same variables have to be raised to the same powers. Right, so I can't combine an x squared with an x to the third, or a y squared with y to the fourth. It has to be the same powers. So go through here and just point out which of these terms are like terms. So first one would be 4x squared and x squared. So let's go through the checklist. Need 2 things in common. Same variables, but have the same variables, right? X and x. Are they to the same powers? Yes, they are. 2 and 2. So these are like terms. Alright, next one. Same idea. First thing we look for, same variables. 2 variables here are x and y. Alright, so both terms have the same variables. Are those variables to the same powers? Looks like each one I have x to the third, and I have y to the first. So they have the same powers. So these are like terms. Last one, same thing. We look, have the same variables. In this case, they're not the same powers. That's x to the fourth, that's x to the third. So these are not like terms. So when we combine like terms, again, what we're doing is we're adding and subtracting. All we're doing really is counting how many of that type of term we have. Right, so if it's the x squared term, we're asking how many quadratic terms do we have. If it's the x term, we're asking how many linear terms do we have. Alright, so all we're adding and subtracting are the coefficients. We're not doing anything at all with the exponents. We're adding, subtracting, combining like terms. We're not doing anything with the exponents. We're only adding and subtracting the coefficients. So here's an example here. So we're going to go through, we're going to look for like terms. So I'm going to start with this first term, 5x to the third. Any other x to the third term is going to be a like term with that. So 3x to the third would be a like term with that. If I combine those two together, I'll have 8x to the third. Right, next time I look for is my quadratic terms. I have a negative 4x squared. That'd be a like term with 2x squared. Put those together, I have negative 2x squared. Right, next thing I have is my linear terms. Negative 8x and positive 4x. Put those together, I have negative 4x. Right, my last two would be my constant terms, which are what we call numbers, constant terms. Negative 6, positive 3. Put them together, that's negative 3. Alright, so you got the same idea there below. There's 8 problems for you to practice combining like terms. Remember, we're only combining terms that have the same variables to the same powers, and we're not doing anything with the exponents. Alright, so make sure you follow these rules, not just on this worksheet, but everything we do with algebra is going to follow these same rules. Alright, so just said we're adding and subtracting polynomials. We can only combine like terms. Right, so there's some terms we can't add together. We just got to leave them separate. With multiplication, it's a little different. We can multiply any polynomials together. The only thing we have to do is make sure we follow our rules for multiplying polynomials. So to multiply numbers, those don't change. So our coefficients, we're going to multiply because our coefficients are just numbers, right? We know how to multiply numbers. We did that way back in the first unit. And the next things we're going to do is we're going to add the exponents. Alright, so we multiply by another, multiply a number by itself more times, right? That increases the exponent. That adds another power of that number. So that's why we're adding the exponents. Now, one thing to remember is you need to distribute through parentheses. Right, all the way through the parentheses, not just to the first term. And at the very end, we always want to go through, make the problem as simple as possible by combining like terms at the end. Alright, so here's an example. We've got 3x to the third. We're multiplying by this whole quantity, 5x squared minus 4x plus 8. So first thing to remember is rule number 3, distribute through parentheses. Alright, so I got to multiply all 3 of these. So first thing I'm going to do is multiply coefficients. So 3 times 5. 3 times 5 is 15. Multiply coefficients. Next thing is add the exponents. It's going to be x to 3 plus 2, 5. Next multiplication, same thing. Multiply coefficients. Negative 12 from 3 times 4. X to the third times x. We have x to the fourth. And last, 3 times 8, 24. And that's just going to stay x to the third because there's no more powers of x to add. In this case, there's no like terms combined at the end, so we don't have to do this one on this problem. Right, but as long as we follow those rules, we can multiply any polynomials together. Alright, so there's 8 problems down at the bottom. They're going to take you through this exact same thing. So you're going to be multiplying. Make sure you distribute through the parentheses. Multiply every term inside by that term outside. Alright, be careful. We're going to multiply our coefficients, add our exponents together. If there are any like terms at the end, make sure you combine those. So last thing is we're multiplying a polynomial with more than one term. by another polynomial with more than one term. So what we need to do now is still make sure we distribute. Now we have to make sure we distribute everything in one set of parentheses. It's everything in the other set of parentheses. So easy way to remember this, just make sure you multiply everything by everything. Alright, so we're multiplying two that have two terms, like this first example. Right, we have a phrase for that to help you remember. It's called FOIL. We multiply the first terms, right, which would be x times 2x, 2x squared. Then we'd multiply the outer terms, which would be x and 6, so 6x. Then we'd multiply the inner terms, which would be negative 4 and 2x. Then we multiply the last terms, which would be negative 4 and 6. Alright, and the last thing we do at the end is combine our like terms, which are those linear terms in the middle. Second example is a little bit harder because we have more terms. Right now we're multiplying the two terms by three terms. Alright, we can still follow the same idea, just make sure we multiply everything by everything. So everything on the left by everything on the right. So start with 3x times x to the third. Alright, draw the arrows, make sure you hit everything. 3x times negative 3x. And then 3x times 4. Now we start with the 2 and do the same thing. So 2 times x to the third is going to be 2x to the third. 2 times negative 3x is going to be negative 6x. 2 times 4 is going to make 8. So now I'll go through, see if we have any like terms we can combine. Also make sure to write it in descending order. So these are only two like terms, 12x and 6x. Putting into descending order, we got 3x to the fourth. Our next highest order term would be 2x to the third. And then we'll bring in the 9x squared. And then this is going to turn into a positive 6x. And the last term is 8. Alright, so it's a lot of steps involved here. Just make sure you do what you can to keep track of your multiplication. Make sure you're multiplying everything on the left by everything on the right.